Hi, welcome to a terrific Math Tuesday. And as you know, like to complete all of the Delta Math assignments just to make sure I'm not giving you oodles and too much stuff. So it's about 10:30 now. Let's see how long it takes me to finish this one. You'll see I already have a bit of a head start. I have two questions done. Let's see how long it takes.
Okay, there we go. So I'm going to immediately go and change the number of questions in this section because that's really useful, but really time consuming. So I'm actually going to put some extra questions in there, but I'm going to take out the really time consuming questions there. Okay, and then I'm going to give you a walkthrough. All right, team. Now let's go through step by step, type by type, and see how we do them. The first ones are about finding out the equation and the answer from a different situation. So these ones you can use your understanding of these situations to help understand the underlying mathematical concepts. I like to work from concrete to abstract so that I can use my knowledge of the world to solve these things. Here, I see Serenity needs her computer fixed. In the repair store, they worked on it for 4.5 hours and charged her $62 for parts. And the total was this amount of money here. So, what I'm going to do is I want to find out how we arrived at that total 309.50. So, they got to that total by taking the amount for parts, which was $62, and then adding 4.5 hours multiplied by the cost of labor per hour. I'm not sure what it is, so I'm going to call it X. Now I'm going to find out X. So this is a two-step equation, and I have two things to remove. The first thing I'm going to do is subtract 62 from both sides. Always work off your loose addition and subtraction. Gives me 247.50 is equal to 4.5 x. And now my 4.5 times tables is not very good, but I can divide both sides by 4.5. That I'm just going to do on a calculator. Boop. And then I'm going to move the calculator so I can see my numbers. 247, 247.5 divide by 4.5 equals 55. Oh, someone created this question, loves Fibonacci numbers. 55 hours, submit. Yeah. And that's how we solve it. And then we want to think about it this way, that if we add the cost of parts plus the cost per hour times the number of hours, that will give us the total cost here. And so look through their solutions if these are confusing to you and read them, and that will help you out. Okay. But that's how you solve these types of questions. I'll do one more. If Grayson buys milk and oranges at the store and he pays this total, okay, so this is how I would set this up. Here's his total. It's $40.68. Okay. And how did we get there? Well, he bought milk. That was $2.52. And then plus 8 bags of oranges that cost the same amount. So I'm going to say 8 times B for bags of oranges. And then I'll just solve this equation for B. So let's do that. First, subtract away the 2.52 from both sides. I am adding that number here, so I use the opposite, which is subtraction. You'll notice that will add to 0. And that will give me 8b is equal to the result of this here, which is 38.16 is equal to 8b. And now if I divide that out by 8, it's going to be some like 2-cent thing there. I'm going to guess it's $4.77. I'm not sure. Use a calculator. 38.16 divided by 8 equals 4 point. What did I say? Okay, 4.77. All right, so there you go. And now I feel a surge of dopamine. I just feel good that I did that in my head and it was right. I'm very pleased with that. Okay, so you want to practice it that way too. So I asked you to do 3 of those, not too many. Equations in context. So here, members of a baseball team raise this amount of money to go to a tournament. Okay, so they have 13,055.5 to spend. And we don't say 0.5, we say 0.50 because it's money. Okay? And they rented a bus for 835.50. Okay? So this is just a fixed cost, 835.50 plus they're still going to have a little bit of money left over that they can send players. $40 player per meals. Okay, so it's going to be plus 40 times X. Okay, X is the number of players here. And so now I just need to solve for X to find out how many players they can bring. Oh, wait, which one represents the thing? So I have multiple choice here. I want to find the number of things. So what is this? 40 equals this minus that? Well, that's actually true. This one is true here. Why do I know that? Because if I take my equation here and rearrange it by subtracting 835.5 from both sides, you'll notice this is equal to 40x because this is 0. So that's what I would have there. 40x is equal to that. So the answer is A. It's not this. It's not correct. Okay, I'm multiplying the wrong thing. The answer is A. So just do a couple of these to see which one is which, and know that you have to rearrange your answer to find out which of the multiple choice ones is correct. New problem. Okay, under her cell phone plan, it plays a flat cost of 47. So this looks good. There's the flat cost of 47 plus 5 multiplied by G, and that would be $5 per gigabyte. Okay, so this would accurately reflect her cell phone plan, but she wants to keep her bill at 54 per month. So that's the total we're looking for, not 49, 54. So, but this isn't it because it's not 47G. I want this one here, this equation. 5 times the number of gigabytes plus $47 is the flat fee should equal 54. So the answer is C. Here, that one. Boop, submit answer. Hooray! Okay, so that's how you do these. Is you look at the situation and you're going to say which representation is accurate. You want to be able to rearrange equations and do that to see, imagine things as tape measures or imagine things in different ways. Okay, let's keep going. Write an expression from context. I asked you to do 8 of these. Why? Because they're easy to do once you know how to do them. Okay, so Jacob signed up for a streaming music service that costs $6 per month, and it allows him to listen to unlimited music, but he charges 50 cents per download. How much would he have to pay if he downloaded 20 songs? So I'm going to take the amount per download, multiply it by 20 songs. So half a dollar times 20 is $10 plus 6. So that's going to be $16. It's going to cost him. But what will it cost for S songs? Well, that would be the flat fee, $6 plus 0.50 multiplied by the number of songs. Okay, so this is how I will answer these ones. Now, let me walk through this one a little slowly because I'm realizing I'm rushing a little bit here for this skill. Okay, to set up an equation here, I take my fixed cost, $6. I add my variable cost, which is money per song. This is the rate per song. So that's often a clue that I'm going to be multiplying that, like per hour or per song or per jump or whatever. And then I'm going to multiply that by the variable S. This is my equation. And then in order to find out when S is 20, like what if he downloads 20 songs, I just substitute in 6 plus 0.5 times 20. Well, half of 20 is 10, so this is 6 plus 10. That's how I do that. 6 plus 10, last time I checked, was 16. Hooray! Okay, let's do a few of these so I can show you a few examples. So we just got a job. She has an annual salary of $44,000, but each year she stays, she gets a raise of $5,000. Good job. That's a nice job. You'll be making a lot of money pretty soon. After 3 years, she will have gotten $15,000 raise. So 15,000 plus 44,000 is 59,000. Let's put that in. Salary after 5 years is 59,000. Salary after T years would be her initial salary. Wait, that's not her initial salary, 44. There it is, plus 5,000 times T. Why T? Because it's T number of years. They give you what your variable should be there. Submit, enter, hooray. Okay, I'm not going to do any more. I think you got it. Now let's take a look at writing and solving equations in context. These ones are exactly the same as the last ones. They just have weird, funky decimals. Okay, Layla is now riding a taxi from her house to airport. There's a pickup fee of $4.10 plus $3.75 per mile. Okay, the total fare was $64.10. Okay, so the total $64.10. Okay, that's how much she pays, and that starts up with the pickup fee.
which is not variable, that's a constant, $4.10 plus $3.75 per m miles. Okay. Now, from this equation, we have one equation, one unknown. So we can solve for the unknown, and then we'll know how many miles she went. Okay, so let's do that. All right, subtract the 410 from both sides. Gives me $60. 60 is equal to 375 multiplied by m. Is that going even? I can't. It might. It might. What would it be? I don't know. I could do it in my head, but you'd have to look at me staring up at the ceiling for a little while. 60 divided by 3.75. 3 3/4. Okay. 16. Okay, cool. So m is 16. So that's the value of m. But my equation is write and solve an equation. So my equation was 64.10 equals 4.10 plus 3.75 m. That was my equation. That was my answer. Hooray! Okay, so that's how you do these. You create an equation and then solve it. Okay, let's keep going. Finding rates. Oh, this is a really important thing. So be able to find that m value. So our line basically has two ingredients. Okay, well, there's another ingredient, which are the variables. Y. Y is in some relationship with x, but that's affected by a multiplication. We're going to multiply x by m, and we're going to add some value b to it. So really, we just need to find m and b to find the equation of any line. M here, this is the rate of change. And you'll notice that in the other things. This is always the number that has a per in it. Let's say I start 10 kilometers away from you. So y is how far away I am from you, and I'm moving at 100 kilometers an hour. So 100 times the number of hours, plus I start 10 kilometers away from you. Okay. When time is 0, when hours is 0, I will be 10 away from you, notice. So this is the initial value. For every hour I travel, I will move another 100 kilometers away from you. After 1 hour, I will be y is equal to 100 plus 10. I'll be 110 kilometers away from you. Okay, so this is the rate of change. Rate of change. This m is the rate of change. And we want to be able to find that. Let's take a look at this one. When we're looking for rates of change, what we want to look at when we're looking at graphs is we want to find our integer points. I'm going to zoom in here for you, and let's take a look. So here I notice an integer point right here at the point x is 0 and y is -1. Here's another one. Y is 0 and x is -4. So what I have here, if I can just draw on my screen, let me see, where's my screen drawing tools? No, I don't have my screen drawing tools. That's annoying. But anyway, maybe I can get them back. No, I can't. They're gone. But what I can do here is pause the video and then draw you a diagram. All right, here's a beautiful diagram. So notice that I'm focusing in on the points -4, 0 and 0, -1, okay? So what we have here is an example of a rate of change. Let me just zoom out just a little bit there. And then this is the way you want to think about it, okay? What we can imagine here is that when we go down by 1, we go, oh, I'm not pushing shift. Don't do that. That's strange. If I go down by 1 here, I would have to, that's very strange. Okay, if I go down by 1, I would have to go over by 4. This is decreasing by 1 in the y and increasing by 4 in the x. These little triangles that you can draw around your lines will tell you m. M is equal to change in y over change in x. So here we would have our m is equal to -1 over 4. When y goes down by -1, x increases by 4. But what if I went the other way? What if I started here and I went like this? If I decreased x by 4, so let's just say I'm going in that direction there, that's decreased by 4, and then I increase here by +1. What about that? What if I did that way, Mr. Jennings? Well, then the negatives would cancel. Then I would have 1 over negative 4, which is the same thing as negative 1 over 4. What I'm showing you here is that it doesn't matter if I count towards the left or towards the right, just so long as I'm counting in the same kind of way, both ways, and the signs will cancel out. Okay, so that's how you find m in these cases, is you take change in y over change in x. So let's put that in here. Let's zoom out. There we go. Boop. And so this was negative a quarter. That means for every 4 it grows in the x, it decreases by 1 in the y. And that's true all the way along here. If I grow by 4 in the x, I decrease by 1 to down there, from here to here. That's true all the way along that line because the line slope never changes. It's straight. Let's do another one. Here's another one with a graph, and I want to zoom in and take a look and find some integer points. Okay, so let's zoom over here. Here's an integer point right there at the point 0, 1. And I find another one here at negative 2, negative 4. Okay, so here is negative 2, negative 4. It grows by 2 in the x to get here, and then it grows by 5 in the y. So here's my drawing tools. There we go. Let's zoom back out, and I'll show you. So here, it grows from here plus 2, and then this grew plus 5. So I put change in y on top, 5 over change in x. Another way of thinking about this is m is equal to rise over run. All right, so that's 5 over 2. Now let's input that and see what it says. Oh, I need to go back to there we go. Here we go. 5 over 2. Submit answer. Yes. Hooray, it loves it. So let's clear that, clear screen, and then go back. Okay, now let's carry on. And see, they do the same thing. They have my change in y there, my change in x there, and they highlight these things to help me see that when I look at that. Now here, this is one is easy because it's already there. I just read off m. That's the slope or the rate of change. Slope and rate of change are synonyms. Minus 5 over 4. Hooray, that was easy. Let's do another one. Oh, 1/2. That was easy. Just read this number. Okay, cool. Let's do more. Okay, well, this one, we go from negative 1, 0 to 5, 0, 5. So it grew by 1 in the x and 5 in the y. So that would be 5 over 1. It's just 5. Yay, okay, see here? Plus 5 in the y, plus 1 in the x, so 5 over 1 is 5. All right, let's do some more. Because there's some from tables that I want to show you. You can get some from tables here. This is negative a quarter. Here is one from tables, okay? So here, when x grows by 4, y shrinks by 1. So I have negative 1 over 4. That's growth in y over growth in x. Hooray. Okay, so that's how you do these. All right, now let's do table to linear equations. That's the first step to solving these challenging table questions, okay, is you first find m. Let's go ahead and do that. Okay, here I see x is growing by 5. It went from minus 3 and it grew to 2. So that's a growth of 5. If I want, what I can do is I can say change in x is equal to x2 minus x1, okay? And change in y is equal to y2 minus y1. And this will show me the change. Change is like you use subtraction to find how much things changed. So let's do that. I am going to say x1, y1 is this point here, negative 3, 11. I'm just getting that from the table right there, you see? And then the next one, x2, y2, is 2, 1. x2, y2 is equal to 2, 1. So let's find change in x and change in y. Change in x is equal to x2 minus x1. So that's equal to, let's do this in blue, that's equal to x2 is 2. So 2 minus minus 3. 2 minus minus 3 is the same thing as 2 plus 3. Minus and minus is plus. So that's equal to 5, like I was saying. And then what does y do? Well, we went from, here's y2 is 1 minus 11. Okay, so 1 minus 11 is negative 10. All right, so now I have my change in x and my change in y. And my m is equal to change in y, rise, over change in x. So that's equal to negative 10 over 5, which is equal to negative 2. Okay, so there's my m. These are the steps you take to find m. You can train yourself to do this in your head, no problem. You'll absolutely be able to do this with practice. And maybe some caffeine. No, you don't need caffeine to do this. So now what do I know about this line? I know that m is minus 2. So the line is of the form y is equal to mx plus b, but I know m, so I have y is equal to negative 2x plus b. All I need to do is find b. Let's use this point here, 2, 1, to find it. So I know that when y is 1, x is 2. So I have negative 2 times 2 plus b. Okay, cool. So what will that be? Well, let's do this. 1, just evaluating, is equal to negative 4 plus b. What number do I have to add to negative 4 to get 1? Well, 5. Okay, 5 is the answer. Let's see why. Oops. Here. Okay. So how do I do it? I add 5 to both sides. I add 4 to both sides. I'm sorry. I add 4 to both sides. 1 plus 4 is 5. Negative 4 plus 4 is 0. So 5 is equal to b. There we go. Now I take this and I put it in here. What? Well, I had the whole equation of the line less b. So let's put that in. Okay. Y is equal to negative 2x plus 5. That's the answer. So that was very step by step. Y is equal to negative 2x plus 5. Hooray! And let's do more because they're fun. You can do a lot of this one for practice, okay? So here, I look and I see x is growing by 3. That's the change in x. Y grows by 12. So I put 12 over 3 in my head. Oh, that's 4. So y equals 4x plus b. Now substitute in, sure, this point. 1 is equal to 4 times negative 1, which is negative 4, plus some number. Oh, that number is 5. So I have y is equal to 4x plus 5. And now I just check my answer, put in this one. X is 2, so that would be 4 times 2 is 8. 8 plus 5 is 13. Someone made this problem loving Fibonacci numbers. Submit answer, yes. Yay! Do another one in my head. Okay, so x grows by 4, y shrinks by 8. So I have negative 8 over 4, which is negative 2. Y is equal to negative 2x plus b. Substitute in, sure, this point, because I get to work 1. Negative 7 is equal to 1 times negative 2, which is negative 2, plus some number. So that's minus 5. Y is equal to negative 2x minus 5. Yay! Okay, you can train yourself to do this in your head, and then it's a super fun puzzle. You can always take any 2 points and find the equation of the line. If you're ever waiting for a flight and you want to entertain yourself, see if you can do 100 lines. Okay, so that's table of linear equations. Interpret linear equations in context. Okay, these ones just ask you to identify what the different numbers mean. So the height of sunflowers after W weeks is given by this formula. In this case, 11 represents the sunflower's height after 0 weeks. That's the initial value. This number here, the constant number, is usually what we call the initial value. Okay, so that would be the sunflower's height initially after no weeks have passed. We can verify that by putting in 0 for W, and you would have height is equal to 0, because anything times 0 is itself, is 0, plus 11. So height would be 11 at 0 weeks. That's why. Yay, let's do another. Okay, Yusuf is going to the amusement park. He has to pay a set price for admission and other things. Okay, so where were we? I think so. Yusuf is spending $4 per every ride, and then $20 is some kind of flat fee. So $20 would be the amount of money Yusuf will spend if he goes on no rides. Watch. No rides is X. See, X represents the number of rides. So 0 rides would be $0. Doesn't matter, they cost $4. So he still pays $20 to just show up to the amusement park. That's his admission fee. Yay. Okay, so this you want to have this idea, right? Now we get into systems of equations. Okay, these are cool. I really like these guided problems here. So here we know that he buys a total of 11 apples and bananas, and he spent $12. We know that each apple costs $1.50 and each banana costs 60 cents. So first we want to find 3 different ways he could have bought 11 bananas. 11 apples and bananas. That could be 1 apple and 10 bananas. There we go. Try it. It says 1 apple and 11 bananas. Here the X is the number of apples and Y is the number of bananas. So we try that. That indeed, it's 1 apple and 10 bananas. There, try that. Yeah, that's right. Find another combination that adds to 11. Okay, so, let's do, I don't know, 5 apples and 6 bananas. That's another way to buy 11 pieces of fruit. 5 and 6. Try that. That indeed adds to 11. Okay, he maybe bought 11 apples and no bananas. Try that. Okay, 11, 0. Okay, cool. Now plot a line through those points. Okay, so we need to plot 2 points. So I'm going to do 11, 0 and 5, 6. Here's the point 5, 6. Here's the point 11, 0. Notice that every other solution lies along that line. Now determine 3 ways that things could add up to 12. So let's try it. Let's say that plus, I want 9 there. There we go. $3 plus $9. Try it. Okay, that was 2 apples and 15 bananas. That was too many total fruit, but it was the right price, you see? Now let's try another one. Let's try more apples. Let's try that many apples and that many bananas. There's the solution. Okay, I'm kind of being a jerk by just going straight to the solution.
All
6,
right, CCI, this
5.
is
I gotta
your
hurry.
5-minute warning to get
Try
to
it.
class. 5 minutes,
And
2
then one more.
songs.
We're
This
gonna do
is
it
a
all
true
with bananas.
quadruple play Tuesday.
I don't
2
think
more
we'll be able to
songs,
get
I'd
an
read
even
yours
11.
for you.
No, we're not. So try that. No, still not right. There. That's right. Try. I think I already have that one. Come up with a different combination. Okay, let's do. That's to how much dollars? $12, I think. Right? Yes, $12. This will do. This was 4 apples and 10 bananas. Try it. Yes. Now plot these lines. So I'm going to put in the point 410. 410. Notice this is not on the original line, but it creates a new line. Then I'm going to do the other one. The first one, 215. Here's 215. Okay? There's only one point of intersection. It's right there at the point 65. That's the solution. That's both 11 fruit and adds to $12. So it was, if I remember correct, 6 apples and 5 bananas. Was that it? 6 apples and 5 bananas, I think. Yay! So these are really cool. Practice with a few of them and get good at it. Next is solving systems graphically. Okay? Here, they have graphed the lines for you. This is y equals negative 5x minus 8. I love Fibonacci numbers for sure. So this goes down by 5 every 1 that x increases. That's why m is negative 5, and it crosses at negative 8. We notice that they cross at the point 0, negative 8. 0 in the x and negative 8 in the y. I might get a copyright strike from the announcements here. That'd be too bad. Anyway, so that is what it is. Come on in. Welcome. So that's the solution. You have to put it in brackets and put the x first and then the y second. That's 0 in the x and negative 8 in the y. Just where do they cross is this one here. Very straightforward. New problem. So here, they cross on the y-axis. I'll show you a new one. Here, they cross at negative 2, negative 2. So I write that in as negative 2, comma, negative 2, put in the brackets. Hooray. Okay, that's how you do these. Now, to solve these, you need, and this will be the last one I show, and you have to figure out the last one on your own, because, hey, I got to go eat too. Okay, so first I'm going to graph this line. To graph that line, I see that my m is -1 and my b is 4. So I first plot the b, which is 0, 4, and then I'm going to go over 1 and down 1. That's my slope of -1. Now I'm going to plot this line here. I start at -2 because that's my b, but it has a positive m of 2, so it's over 1 and up 2. Then I find the intersection, which is the point 2, 2, and that is my solution. 2, comma 2, end bracket, finish. Hooray! And the people rejoice. Figure this one out on your own. That's your challenge. Yeah. And any questions, absolutely hit me up by email. I hope your math practice has been fruitful on this terrific Tuesday. Bye for now, everyone.